Welcome back to the Building Code Pros Podcast, your expert resource for navigating the world of building codes. In today's episode, we're taking a closer look at a crucial topic. Let's get started. We are launching a deep dive into Chapter 5 of the 2024 International Residential Code. This chapter is entirely dedicated to floors. And honestly, if the floor system isn't right, well, the rest of the structure is built on a shaky foundation, literally and figuratively.
That's absolutely correct, yeah. If you really boil Chapter 5 down, its core mission, it's about two things.
Okay.
Making absolutely sure the floor assembly can handle every load thrown at it, live loads, dead loads, snow loads.
Right.
And maybe even more critically, ensuring those loads get efficiently funneled down.
Yeah.
Down through the vertical load path.
That makes sense. A floor is a massive diaphragm, right? It's got to transfer all that weight.
Exactly, safely down to the supports below.
So let's begin with the basics, which for most houses is going to be wood framing. That's section R502. Before we even talk sizing, what about the materials themselves? Are there strict rules?
Oh, definitely. It starts with identification. Every piece of sawn lumber, it has to carry a grade mark from an accredited agency. You can't just, guess.
No eyeballing it.
Right. And here's one that catches people out sometimes, especially for certain assemblies. If you're using end-jointed lumber in, say, a fire resistance rated assembly, the adhesive matters a lot.
Okay.
It has to be certified as heat resistant. The grade stamp actually needs to say heat resistant adhesive or just HRA.
Huh. Why is that specific detail so critical in a fire?
Well, think about it. In those rated assemblies, we're counting on that structure holding up for a specific time, right?
For evacuation, firefighting.
Exactly. If the adhesive holding those finger joints together fails early because of the heat, the joint goes, the member collapses way faster than planned.
Wow. Yeah, that's a subtle detail with big consequences.
It really is. Life safety stuff.
Okay, moving from standard lumber to engineered products. You see I-joists, glulam, SCL everywhere now. Do they have similar grading?
Yes and no. Their compliance is handled a bit differently. Instead of just a visual grade, they have to conform to specific standards like ASTM D5URI55 for I-joists or ANSI A190.1 for glulam.
So for the builder, what does that mean practically?
It means you absolutely must follow the manufacturer's installation guide. That guide is basically your proof of compliance with those standards. You can't deviate.
Got it. Follow the instructions. Which brings us to the span tables. Everyone loves the span tables, right? They simplify things a lot. But if someone's listening, maybe planning a remodel or a new build, how do they know which table to even open?
This is probably the first common sizing mistake we see. There are two main prescriptive tables, and it's all based on what the room is used for.
Yeah.
Table R502.3.111, that one's only for your lighter load areas. Think bedrooms, hallways, just serving bedrooms, maybe an attic you get to with fixed stairs.
Lighter loads, so like 30 PSF live load.
Exactly. 30 pounds per square foot live load, 20 PSF dead load max.
And then table R502.3.1 must be for everything else, the heavier areas.
That's the one. That covers your general living areas, kitchens, dining rooms, basically anywhere you'd expect more people, heavier furniture. That assumes a 40 pounds per square foot live load.
And using the wrong one is a problem.
Oh, yeah. If you accidentally use that lighter 30 PS table for, say, a kitchen, maybe it passes inspection, maybe. But that floor, it's going to feel bouncy. It'll flex when you walk, especially with heavy appliances. Homeowner won't be happy.
Right. So the tables only work if you pick the right one based on the room's actual use.
Precisely. You got to match the table to the load.
Okay, let's talk cantilevers. Sticking out past the wall. If I have a 2x10 floor joist, how far can I actually push that out? Is there a hard limit?
There is a hard cap. The code says the cantilever span itself cannot be more than the nominal depth of the joist.
So for a 2x10, that's nominally 10 inches deep. So I can't go out more than 10 inches.
Well, technically the nominal depth, which is 10 inches.
Yeah.
But the real governor is the back span. What's holding it down inside the building?
The leverage part.
Exactly. Cantilevers create huge uplift forces on the joist ends inside the building. Have to counteract that.
So you need enough joist inside the building to balance the part sticking out. How does that ratio change, say, between little bump-out window seat versus a full balcony?
It changes quite a bit, yeah, based on what that cantilever is holding up. If it's just supporting a light frame wall and maybe some roof load, you need a minimum 3-to-1 backspan ratio.
3-to-1. So 3 feet inside for every 1 foot sticking out.
That's right. 3 feet firmly anchored inside.
And for a balcony, More load, more exposure.
Right. For an exterior balcony, which definitely has higher potential loads, the requirement actually shifts to a 2-to-1 backspan ratio.
Wait, 2-to-1, that seems less stringent. Why?
It might seem counterintuitive, but the tables associated with that ratio often require larger joists or closer spacing for the balcony itself, reflecting the higher load. The key point, though, for either ratio is that you must have connections designed to resist that uplift. That back end has to be held down securely.
Or it just becomes a seesaw.
A structural seesaw waiting to fail.
Yep.
Absolutely.
Okay, high-stakes stuff there. Let's shift to focus a bit to connections, keeping things stable laterally. Sections R502.6 and R502.7. Starting with bearing length. How much joist needs to sit on the support, and why more on masonry or concrete?
Good question. It comes down to the crushing strength of the materials involved. If your wood joist is sitting on wood or metal framing, 1.5 inches of bearing is usually enough.
Okay.
But masonry and concrete, they're much denser, less forgiving. If you don't spread that load out over enough area on the wood joist end...
The wood could crush.
Exactly. The wood fibers can start to crush over time. That's why the code demands a minimum 3 inches of bearing on masonry or concrete.
3 inches minimum, got it. What if I'm lapping joists, say over a central beam or girder?
When you lap joists over a support like that, you need at least a 3-inch overlap.
3 inches again.
Yep. And that lap needs to be nailed together properly, minimum of 3 10D face nails. That 3-inch lap and the nailing provide enough connection to basically make those two joists act like one continuous member over the support.
Okay, makes sense. Now, lateral stability. It's not just about holding weight upright.
Yeah.
The floor needs to resist twisting or moving sideways.
Absolutely critical. That's what lateral restraint is for, and it's required at the ends of every joist.
How do you achieve that?
2 main ways. You can install full-depth solid blocking between the joists, usually nominal 2-inch thick material, or you nail the joist ends securely to a full-depth header, or more commonly, a rim joist.
That locks the ends in place. Does that need to extend out into the middle of the span?
It does, yeah, specifically for deeper joists, if you're using joists that are deeper than a nominal 2x12.
So 2x14s, I-joists, maybe?
Right. The code figures those deeper, narrower members are just inherently more likely to want to twist or roll on their side. So for those, you need bridging.
Bridging, like those little X braces sometimes.
Can be. Bridging can be solid blocking, like at the ends, diagonal wood bracing, metal strap bracing, or even just a continuous 1x3 strip nailed flat across the bottom of the joists.
And how often do you need that?
At intervals no more than 8 feet apart down the span. It just ties everything together, prevents that rotation, and really stiffens up the whole floor system.
Okay, now here's a big one. Section R502.8. Cutting, drilling, and notching joists. This feels like where a lot of field modifications happen and where problems start.
You are absolutely right. This is probably the most common way structural integrity gets compromised after framing is up, especially with sawn lumber.
So for standard lumber joists, what's the absolute don't do this rule for notching?
The big one, the unforgiving one. No notches allowed in the middle 1/3 of the joist's span.
Period. The middle third. Why there?
Think about how a joist bends under load. The maximum bending stress happens right in the middle of the span. The top edge is in compression, the bottom edge is in tension. A notch there cuts right through those critical fibers.
Catastrophic, basically.
It drastically reduces the load capacity. It's asking for failure.
So you can notch near the ends, but carefully.
Yes, there are limits. End notches can't be deeper than 1/4 of the joist depth. Notches elsewhere outside that middle third can't be deeper than 1/6 the depth and not longer than 1/3 the depth. But honestly, avoiding notches is always best if you can.
What about holes for wires, pipes?
Holes are generally better than notches because they displace less material, especially if kept away from the top and bottom edges. The rule is holes can't be bigger than 1/3 the joist depth.
Okay.
And critically, they have to be at least 2 inches away from the top edge, 2 inches from the bottom edge, and also 2 inches away from any other hole or notch. There are helpful figures in the code book showing these zones.
Keep them away from the edges and each other. That makes sense.
Yeah.
Now, what about engineered wood? I-joists, trusses, LVLs, kind of drill those?
This is where it gets really simple but also really strict. The rule for engineered wood products is basically
No cutting, notching, or drilling at all.
Not unless it is explicitly permitted by the manufacturer's recommendations or literature for that specific product. Many allow some holes in the web, but only in specific locations and sizes shown in their details.
And if the manufacturer's guide doesn't show the hole you need?
Then you stop. You cannot do it without getting specific approval from a registered design professional and engineer. You just can't assume. Modifying engineered wood outside the manufacturer's limits voids its structural capacity.
Okay, that's a very clear line. Engineered wood. Ask first, check the manual, or call an engineer.
That's the safe way. Don't guess.
All right, let's briefly touch on some alternative systems. Cold-formed steel framing, R505. See this more in some multifamily or light commercial. What's a key difference compared to wood framing?
Probably the biggest fundamental difference is the need for precision alignment, what the code calls inline framing.
Inline framing.
Yeah. R505 essentially requires that the steel floor joists line up vertically, directly over the load-bearing studs below them.
Why is that alignment so critical for steel?
Because those steel members, especially the C-shapes, have thin flanges and webs compared to solid wood. If they aren't aligned, the load doesn't transfer straight down the strong part, the web. It can cause the thinner flanges or the track to buckle or cripple.
Web crippling. Sounds bad.
It is. It's a localized failure. And to prevent that at supports, steel joists almost always need bearing stiffeners.
Stiffeners. Like extra pieces of steel.
Exactly. Usually small pieces of steel fitted inside the C-shape right at the bearing point to reinforce the web against crushing. They're required at each bearing location, and if there's a load-bearing wall sitting on top of that joist, the stiffener usually needs to be even thicker.
Makes sense. More reinforcement for more load. And cutting or notching steel joists.
Big no-no. R505.3.5 is explicit. Flanges and lips of cold-formed steel framing members shall not be cut or notched ever.
Okay, very clear. Don't cut the thin steel. Let's wrap up with something super common and honestly a place where we see a lot of issues. Exterior decks. R507. Where do builders or even DIYers tend to fall short on deck code?
Two big areas consistently pop up. Footings and fasteners. Let's start with footings.
Oh.
All deck footings have to go down at least 12 inches below undisturbed ground. That's the baseline minimum. But if that deck is attached to the house and the house foundation is protected from frost, which most are.
Then the deck footings need frost protection too.
Exactly. They need to extend down below the local frost line, just like the house foundation. This is missed surprisingly often. People think of decks as separate, but if attached, they need that same level of protection against frost heave.
Is there an exception?
Yeah, there is one main exception. Small, freestanding decks. If it's not attached to the house, under 200 square feet, and the deck surface is 20 inches or less above the ground, then you typically don't need the frost protection for the footings.
Okay, so attached decks need frost footings.
Yeah.
What was the second common issue?
Yeah.
Fasteners.
Fasteners and connectors, and really the issue is corrosion. The materials first. Lumber needs to be at least number 2 grade or better, and obviously pressure-treated or naturally durable wood. Composites need to meet their standard, ASTM D7032.
Right, the basics.
But it's the metal holding it all together. The screws, nails, bolts, hangers. That's where decks often fail prematurely, especially near the coast.
The salt air is brutal on metal.
Extremely. Standard galvanized hardware just won't cut it long-term in a marine environment. The code is very specific here.
What does it require?
If your fasteners or connectors are exposed to saltwater, or even just located within 300 feet of a saltwater shoreline, they must be stainless steel. Type 304 or 316 typically.
Not just recommended, but required.
Absolutely required. It's not an optional upgrade for longevity. It's considered a minimum structural requirement for life safety in those corrosive environments. Using the wrong fasteners there is setting the deck up for a potentially dangerous failure down the road.
Wow. That 300-foot rule is a really critical detail for coastal builders. Saves massive headaches and liability later.
Huge. Pay attention to Table R507.2.3. It spells out the fastener requirements based on environment.
Okay, we've covered a lot of ground, from basic wood framing to steel and decks. If our listeners are going to remember just a few key things from this Chapter 5 deep dive, what should they be?
All right, 4 big takeaways. First, the code gives you prescriptive tools, like span tables, but context is everything. You must use the right table for the right load. 40 PS for living areas, 30 for sleeping areas. Don't mix them up.
Right. Context matters. Number 2.
Modifications, cutting, notching, drilling are super restricted. For sawn lumber, know the limits, especially. No notches in the middle third of the span. For engineered wood or steel, the rule is basically don't touch it unless the manufacturer or an engineer explicitly says you can.
Got it. Assume no unless proven otherwise. Third point.
Think beyond just vertical strength. Lateral stability is crucial. Joists need restraint at the ends blocking or rim joists, and deeper joists, over 2 by 12 nominal, need bridging out in the span to stop them from twisting. A stable floor is a stiff floor.
Good point. Stability equals stiffness. And the final takeaway.
When you go outside, especially with decks, corrosion control is paramount. Use the right treated lumber or composites, sure, but pay extra attention to fasteners. Near salt water. Stainless steel isn't optional, it's required by code. Check that table.
Excellent summary. Get the loads right, don't cut things you shouldn't, keep it stable sideways, and use the right metal outdoors.
That's the gist of it. Understanding these nuances in Chapter 5 really separates a basic code minimum floor from one that's truly well-built, durable, and performs well for the homeowner.
And that's our breakdown for today. We hope this gives you a clearer understanding of the topic. For more articles and resources, be sure to visit buildingcodepros.com. Join us next time for another episode. Thanks for listening.